Hello everyone, in this video I'm going to be going through the thinking process of appointment number 2 on hemophilia. So hemophilia is an X-linked recessive disorder. So if it's an X-linked recessive disorder, that means that I need to worry about my X and Y chromosomes, whether I'm a female or male. And if it's a recessive disorder, I could start and just make the key right away. I could say that hemophilia, the disease, let's make a little h, is recessive, and we'll say that normal is the dominant trait, so big H. All right. And it's a disorder that involves the difficulty of the blood to clot after a cut. So if you haven't already, make sure you watch the video just to kind of get an idea of what it is. It's only about 2 minutes or so. So let's say you're a genetic counselor and Sarah and Mikhail come into your office. And they're planning on having children, but Mikhail has hemophilia, and Sarah's mother surprisingly had hemophilia, but her father did not. And it also gives us some extra information that Sarah, her brother, and her father did not have hemophilia. All right. So to start this, let's maybe start with Mikhail and Sarah. So I'm going to draw Sarah, the girl, as a circle. Right? And if you're married or having children, it's a horizontal line directly across. And I could also label them too. Here's Sarah, and here's Mikhail. All right. And remember, Mikhail has hemophilia. Right, and it really doesn't tell us any information about Mikhail's family, but it does give us some information about Sarah's family. It also tells us that Sarah has a brother. So if you're in the same generation, that's going to be along the same lines. You don't have to do this, but you could label this like this is the second generation right here. Right? That's supposed to be a 2. So make it maybe a little bit easier to see. Okay. And if they're siblings, we don't draw a line horizontally across because that means that they are having kids. And hopefully Sarah and her brother are not. So we're going to have 2 vertical lines go up and then a horizontal line across. Right? That shows that they're siblings. So notice the difference. And then what they have in common is they have the same parents. So I'm going to draw a vertical line going up, and then their parents are married. So just like Sarah and Mikhail, they'll have a line going across as well. Now, from this information, it says that Sarah's mother surprisingly had hemophilia. And that's interesting because usually females do not have the recessive traits when it comes to sex-linked traits. Right? Just like more males are colorblind than females, it would be the same thing with hemophilia. More males typically have hemophilia. Okay. So since this is an X-linked trait, I'm not going to worry about the H's, the alleles just yet. I just worry about my X's and Y's. So this is a female circle, XX, male, XY, XY for male, XX for female, XY for male. So this, by the way, is going to be the first generation. They're Sarah's parents, and then the second generation, Sarah Mikhail and Sarah's brother. All right, before I start making alleles, we could kind of make a key of what I'm expecting here. So here I have XY, because it's square and male, XX, XX, and then XY. So if someone has hemophilia, all right, they're affected, they would have the lowercase h, and since this is a male, there's no allele on the Y, so I'm just not going to have anything there. And then if a female has hemophilia, they have to have both recessive alleles in order to be affected. And then if I don't have hemophilia, if I'm a male, I'd just be the dominant allele, nothing goes to the Y. And then if I'm a female, you definitely have the dominant allele, and we actually don't know if you're a carrier or not. We would have to have more information for that. All right, so with that in mind, let's try to fill this out. So this person, the mother, is affected with hemophilia, so she would have both recessive alleles. The father does not, so dominant. Anyone who does not have it automatically has that big H, right? Mikhail does have hemophilia, so that's going to be a lowercase h. And then Sarah, we're not sure what she has here just yet. But we could look at this pedigree. That's why we make it, to get this extra information that we don't know just by looking at someone. And we see that, well, where did Sarah get this dominant allele from? Right? Definitely didn't get it from her mother. Right? So this X with the big H on it had to come from the father. We also know it's this big H right here because the father definitely didn't pass down the Y to Sarah because Sarah's not a guy. She had to get this X with the big H, which means that this chromosome had to come from the mother. And the only allele that the mom could possibly pass down is that little h, right? Whether it's the left or right one, she's passing down a small h. All right, so now we know Sarah's genotype. Right, now we know that Sarah's genotype and Mikhail's genotype. We could go to our Punnett square. I'm going to draw Mikhail up here just because I always draw the guys up here and then the woman on the side for when it comes to Punnett squares. So there's Mikhail, Sarah, XY for male, XX for female. Mikhail has hemophilia, so little h, and Sarah is a carrier for hemophilia, what we found. Her mom passed down that recessive allele. So if I do the cross here, I get something like this. Right. Now, for the sake of time, you can fill out these genotype ratios and everything, but I'm just going to kind of answer the question up here. So if they have a girl, what are the chances that she will have hemophilia? So I'm only going to focus on the females right here, right? These two boxes. And then if you're this box, you have the dominant allele, well, you're going to be normal. And if you have both recessive alleles, then you'll have hemophilia. So it looks like that you have a 1 in 2 chance of being normal, 1 in 2 chance of having hemophilia. So it's a 50% chance if you're a girl. So let's look at the guys now. Just focusing on the guy column. Here we've got a dominant allele, so that person would be normal. Right? Recessive allele, this is the only allele this child would get, and they would also have hemophilia as well. So 1 out of 2 normal, 1 out of 2 would have hemophilia. So it's actually the exact same odds, whether you're a male or female. That's not always the case, right? A lot of times when it comes to X-linked inheritance, the males have a greater chance of getting that recessive trait, whatever it ends up being. All right. So we've done the pedigree to figure out genotype. We've used that genotype to figure out our percentages. And now it's our goal just to kind of explain what did we do here? And can we use our bioterminology to explain what's happening? So what I already did is I already wrote this up, right, the answer to this. So if you want, you could pause the video if you need to. Right. Really what I'm looking for here is can you use the terminology well? Right, and can you use it in the context of explaining what you did? Right, so notice I'm not looking for too much. So I said Sarah's phenotype is normal, so she has the dominant allele. Right? However, her mother could only pass down the recessive allele, so Sarah's genotype is big H, little h, and those are on their X chromosomes. With Sarah and Mikhail's genotypes, just a second. With Sarah and Mikhail's genotypes, I used a Punnett square to determine their child's risk of having hemophilia. Right. So one thing also notice is that we decided last minute that you do not need to use these terms, but if you wanted to use these terms, you could. You could say, hey, hemophilia is a sex-linked disease. Right. So hopefully going through this key step by step is helpful, and I'll see you guys later.